Good afternoon, all of you. My name is MD Parvez, and today we will discuss about center of mass. So let us start. Center of mass. So what is center of mass? Its short form is we use COM. Okay. So what is center of mass? Actually, in any object, in any given object, the point at which all mass means it is called complete mass. Complete mass of given object is assumed to be concentrated at that point. Okay, means suppose we have an object. Suppose in any given object, the point at which all mass means complete mass of given object is assumed. This is very important. This is assumed. Why assumed? I will discuss further. Assumed to be concentrated at that point. Okay. Suppose we have, like, suppose this is object. Okay. This is circle actually, or plate. Okay, this is plate. So in plate, the center of mass is basically the center of geometrical center actually. So there are two types of object, regular and irregular. Okay. So suppose I note down here, there are two types of object with respect to the shape in this world. First is regular object. Like symmetrical. This is symmetrical object. Okay. Means suppose we have plate or we have ring, circular ring. So center of mass is basically the center of geometrical center actually. Okay. Suppose we have triangle, equilateral triangle. This all sides are equal. So this is center of mass is basically the centroid of that object. Okay. Suppose we have plate. Okay. Circular plate. So center of mass is basically the center of that plate. Okay. So this is basically the regular object, like symmetrical object. But in case of irregular, like suppose in irregular object, the center of mass is, the position of center of mass is different. Position of center of mass is different because why different? Suppose we have like that semicircular disc. So center of mass value is different. In case of, like, suppose a hemispherical object, center of mass is different. Okay. Now there are two types of body is assumed in this world. Okay. First, point object. First, point object. Second, continuous object. Second, continuous object. In case of point object, actually we know that there are three types of axes: x, y, and z. Okay? So suppose this is x axis. Now here I will explain about point object. Okay. Suppose this is x axis and suppose this is y axis. Okay. And now suppose this is z axis. Okay. So assume that there are three types of three particles present. Like this is m1 at a distance. This is 0, 0, and this is r1. Means this is x1, y1, z1. Okay. Actually z1 is 0 in xy plane, but no doubt here x1, y1, z1 is a location of m1, and suppose this is m2. Okay. So here x2, y2, and z2 is the location of m2 with respect to this origin. Okay. And suppose this is okay, there are two types of object present here. So x center of mass is here. For a point object, x center of mass is m1x1 plus m2x2. Actually, I have taken here only 2 points, so I write here only for 2 points only. Okay, m1x1 plus m2x2 upon summation of m means m1 plus m2. And here y center of mass is basically for point mass. I have assumed that it is a point mass. Okay, so here y center of mass is m1 y1 plus m2 y2. Okay, here if there are many particles present, then we continue like m1 x1 plus m2 x2 plus m3 x3, that's on. Okay, so here m1 y1 plus m2 y2 upon summation of m means m1 plus m2. And z center of mass is m1 z1 plus m2 z2 upon m1 plus m2. Okay. But in the case of continuous mass, and we write a note, in case of point mass, x center of mass is summation of mx upon summation of m, like here mixi from I equals to like 1 to n, and here mi from I equals to 1 to n, anything. Okay. And y center of mass is similar, like y center of mass is equals to summation of mi yi upon summation of mi, I equals to from 1 to n and I equals to from 1 to n. Similarly, z center of mass equals to summation of mi zi upon summation of zi, and I from 1 to n and I from 1 to n. Okay. Now further, in case of continuous mass, I have already cleared that there are two types of mass object, like first point mass and second is continuous mass. So in case of continuous mass, x center of mass is integration of x dm upon integration of dm. Similarly, y center of mass is basically integration of y dm upon integration of dm. Okay. Now z center of mass in the case of continuous mass is integration of z dm upon integration of dm. Now Suppose we have to calculate the center of mass of semi circular ring. Okay, now this is semicircular ring. Okay, and suppose mass is given, mass is m, and radius value is suppose r. Okay, so first here we have to draw axis, like this is x axis, okay, and this is y axis, and this is z axis. Now this is 0. Okay, now actually mass is continuously mass here concentrated along the length of this ring. Actually this is semicircular ring, so mass is concentrated along the circumference, semi-circumference, half circumference of this ring. Okay, so step 1 here. Step 1, first we select a small element. First we select a small element from given semicircular ring. Okay, first we select a small element from given semicircular ring. Okay, step 2, try to calculate the value of center of mass due to semicircular, due to this small element, okay. Now third, actually we have, this is semicircular and this is axis, this is x axis and this is y axis. So first we have to select a small element, means this is small element, suppose this is real element. Okay, and now this is real element, and here total angle is pi. Okay, so total angle is pi, and suppose this is d phi angle and this is suppose phi angle. Okay, so this is basically radius r. Now this is the x position of, this is the x position of this real element. Suppose the mass of this small element is dm. Okay, so this is the x position, this is r. Okay, this is r. So what is the value of this component? R cos phi. This is r cos phi, this is r. Okay, so this is cos component, this length is r cos phi and this length is r sin phi. Okay, now we know the mass is concentrated along the length. So here there are three types of density. Here mass is concentrated along the length, so mass per unit length, lambda we have used here. So lambda equals to total mass of ring upon the length of this semicircular ring. So complete circle value of circumference is 2 pi r, but it is half circle. So half circle means 2 pi r by 2. 2 pi r by 2. Actually this is the complete circle. Suppose we have complete circle. So value of total length is 2 pi r, but here it is given half circle, so 2 pi r by 2. So mass upon pi r. And for this dl element, actually lambda is the property of given object. So lambda is same also for this dm. Lambda is also same for small element. Okay, small element. Now for small element, for small element, lambda equals to mass of small element dm upon length of small element. Actually this length is an arc, and we know that arc length equals to radius into subtended angle. Subtended angle. Okay, so arc length here, radius equals to r, and this angle is subtended by this small element, so angle is d phi. So arc d phi is the arc length. Okay, so suppose arc length is dl, so like this is dl. Now here mass upon length of this arc length is dl, so here mention dl, and dm upon value of dl is r d phi, so r d phi. Okay, and also this length, this lambda is also equals to m upon pi r. Okay, so here we can write m upon pi r. Now okay, so for x center of mass, we know in the case of continuous mass, x center of mass value is integration of x dm upon integration of dm. Now here x value for this element is this is x value. Okay, this is x value, and this value is r cos phi. So here we can r cos phi into dm. Value of dm here, value of dm is lambda into r d phi. So here value is lambda r d phi upon value of dm. Actually if we integrate the small particle, then we get complete semicircle. Okay, so we integrate from this d element is varied from 0 angle to pi angle. So here we can 0 to pi angle. Okay, now now x center of mass, equals to here r square lambda cos phi d phi 0 to pi upon integration of dm is m. X center of mass is equals to r square lambda upon m and integration of cos phi d phi. Okay, now further x center of mass equals to r square lambda upon m, and value of cos phi, actually value of cos phi is plus sin phi. Okay, and sin phi from 0 to pi. So sin phi from 0 to pi, and further x center of mass equals to r square lambda upon m sin phi, upper limit is pi, so put here sin pi minus sine 0. So x center of mass equals to r square lambda upon m into sine phi value is 0 and sine 0 value is also 0. So x center of mass is 0 in the case of semicircular ring. Okay. Now for y center of mass equals to, we have value for continuous body y dm upon integration of dm. Okay. Now this is the semicircular ring. Okay, and this is the x axis and this is the y axis. Okay. Now here this is small dm element and this is angle, suppose d phi, and this angle suppose phi. So y component for this dl element is, this is r basically, this is r. So this is r sine phi. Okay. So in the case of y center of mass for dl element, y center of mass is equals to integration of value of phi here is r sine phi. Value here phi value is r sine phi, and value of dm, actually I have already discussed about lambda equals to mass upon pi r, and this value equals to dm upon, this is dl. Okay, and lambda equals to mass upon pi r equals to dm upon, this is dl arc length, and arc length is r d phi. Okay, so dm value is here lambda into r d phi. Okay, now here integration of dm, actually this is m, this is y center of mass equals to, this is r square, this is lambda, and this is sine phi d phi from 0 to pi. Okay, now integration of dm is basically m. Okay, integration of dm is basically m. Now integration of sine phi is r square lambda upon m, and integration of sine phi from 0 to pi. So value of integration of sine phi is minus cos phi. Okay, integration of sine phi is minus cos phi, lower limit is 0 and upper limit is pi. Now further, y center of mass equals to r square lambda upon mass minus cos phi. So minus cos, upper limit is pi. Okay, minus minus plus cos 0. So y center of mass equals to r square lambda upon m. Cos pi value is minus 1, minus minus plus 1. Okay, and cos 0 is also plus 1. So y center of mass equals to r square. Value of lambda is here mass upon pi r. So put here mass upon pi r, and this is already mass here, into 2. Okay, into 2. Now this mass cancels out, r cancels out. So y center of mass is 2r upon pi. In the case of semicircular wire ring, the y center of mass value is 2r by pi. Thank you.